Good morning, Year 12. Coming to you live from Carshalton Girls School. And this is my attempt at topic 4, Key Assessment 3. All right, all about the seed banks. And seed banks is a favourite, it appears, of the examiners. So something you definitely need to get your head around. And as I said, why not go and visit, when you get a chance, the actual Millennium Seed Bank at Wakehurst Place. Really nice day out. Good cake in a cafe as well. So we start off talking about, it talks to you about this seed bank, okay, keeping lots and lots of seeds from different food crops, okay. State suitable conditions for keeping the seeds in the seed bank. Well, effectively, you don't want these seeds to be germinating too early, or you don't want them to be decaying or decomposing, all right? So if you think about food that you have, how do you stop that from decaying and decomposing? Well, you're going to have very low temperature, potentially freezing, okay, and you're going to have dry conditions as well. Sorry about this. Okay, so very low temperature and dry conditions, because water tends to cause decomposition as well. Also, germination is triggered by temperature and by dry conditions, which is something you don't necessarily know yet, but you will do by the end of the course. A lot of people write light. Now think about seeds. Seeds can actually respond to light, but they're not responding to light intensity. They're generally responding to day length. Okay, so light is not going to be something that you're going to have in your answer here. Okay, so that's really, really, really important. That's how they're going to be stored. They're going to be stored in really low temperatures. All right. So very, very cold and dry conditions, yeah? So now we've got a multiple choice question. As always with these things, we need to have a look at it and try and eliminate things. So many seeds in the SGSV store store food in the form of starch. There is lots of starch in seeds. Why does food store in the seeds contain starch rather than cellulose? Okay. Now we know that cellulose is a straight-chain structural carbohydrate. Starch is branched, okay, because it's a storage compound, but you do need to be able to hydrolyse that. So let's have a look at what we're thinking here for the answer. Now, as I said, if you know the answer, you know the answer with these things, that's great, but if you don't, you need to work out a way of trying to eliminate some of the other ones. So starch can be stored for longer because it has 1,4 bonds. Cellulose has got 1,4 bonds as well. In fact, it's only got 1,4 bonds. So that is not going to be the answer, because that doesn't, what's the word I'm looking for? It doesn't distinguish between the two types of carbohydrate, the two polysaccharides. Starch has more mineral ions than cellulose. Well, neither of them have mineral ions, okay, because they are carbohydrates, so they contain carbon, hydrogen, 8 means oxygen, so they don't have mineral ions in anyway, so that's not going to be right. Starch is more compact than cellulose because it has 1,6 glycosidic bonds. Okay, now the 1,6 bonds give it the branching, which doesn't necessarily increase the compactness. It is true that starch is more compact than cellulose, but the compactness is really about the fact that it forms a helix, okay, that it winds around. So that's not looking particularly tempting to me either. It's more tempting than A and B. A and B are definitely wrong. So let's have a look at C. Starch is branched and supplies energy more quickly than cellulose. If we look at our starch down here, we've got our 1,4 bonds, and then we've got every now and again some 1,6s coming off it. Okay, that gives us more contact points, so it gives us more hydrolyzation points, and we're going to be able to get that energy in the form of glucose quicker. Okay, so C is our correct answer there. And on the same lines of what I've just been saying, explain why starch must be broken down before it can be used by the cells of a growing plant. Now, starch is a storage molecule, all right? It's big, it's insoluble, you can't transport it, it's just there, being stored ready for use. But as we've seen down here, it is hydrolyzed, okay? So what is it hydrolyzed into? Well, starch is a polysaccharide of glucose, all right? So we want to produce glucose because glucose is a useful monosaccharide. We know that it can be used for things like respiration, okay? And that would be our second one. We need to turn it into glucose for respiration. All right, if you look at the mark scheme, it does give you other ideas about it being soluble and about it being transported. But I wouldn't be thinking beyond that, to be fair, myself. I'm immediately thinking about why do I need starch to be broken down? Well, I need glucose. And why do I need glucose? The first thing that comes into my head when I think about glucose is respiration. All right, and if you simply write, it produces glucose to be used in respiration, that's a sentence, 2 marks, happy days, move on. Right, these last 2 bits are a bit more tricky, okay, because there's some subtleties in it. It's a question 6, so it's towards the end of the paper, so you know that there's going to be some trickiness in there. All right, so the purpose of SGV is to store seeds for use in the future, 50 or more years from now. Seeds from these varieties of maize were tested to see how the effects of long periods of storage. The results of these tests are shown in the graph. So let's have a quick look at the graph. What does this show? Well, it's effectively showing that variety C is keeping, it's not germinating effectively after 60 years. It's being able to be stored for much longer periods of time, okay? And conversely, variety A loses its viability effectively or starts to germinate after about, well, nearly 50 years, okay? And obviously, variety B is somewhere in the middle. How are they going to use these results? Now, the first thing to say is seed banks are conservation things, okay? They're conservation organisations. They're not being used to work out which plant is best or worst or which one we want to use in the future. They want to conserve the seeds. So they want to, after 50 or more years down the line, they want to have some variety A, some variety B, and some variety C. What a lot of people go is, well, what this means is that variety A lasts for a lot longer, therefore we'll grow loads of variety A seeds because, great, that's going to last for longer. That's not what this is about, okay? This is a conservation effort. So we want to keep all of those things intact, all right? What does this graph show? All right, if you're a scientist looking at the graph, what does it show? Well, it shows that seeds can be kept for different periods of time, okay? And that they will no longer become useful or be able to grow after different periods of time. Now, you cannot use the word germination because you're just lifting stuff off the graph then. So what does germination mean? Well, germination is about the plant growing. So if they're not germinating, okay, it means that they're not growing or they're no longer useful. And that's going to be in different times. So scientists look at this are going to go, well, we can't treat these 3 varieties the same. Okay? So different seeds, different rates, all right? And therefore, what we're going to have to do is we're going to have to test them, all right? Now, regular testing would be useful, all right? But if you look at this more lightly, once you've been having this for a number of years, okay, what you can say is, right, well, when it gets towards 50 years, I want to start testing or germinating some of variety A. At this point, I don't have to do B and I don't have to do C. As it gets close to 60 years, I'm going to have to start to test some of these seeds from B, okay? And then obviously we don't know where C ends up at, but we know when we might have to start to look at the viability of these seeds, okay? Now, why are you going to have to grow these seeds after sort of 40-something years, 50-something years and more? Well, the whole point of regrowing them is that you can recollect the seeds. So we just said know when to test. And the whole point of that is you can regrow and collect fresh seeds, which you then know if you've got variety A, you can store them for around about 50 years, and you can store the Bs for around about 60 years. So this isn't about finding out the best or the worst. This is about how do I use the results to conserve all of those varieties. And last but not least, so very wordy, doesn't mean that it's not important. SGV keeps seeds from more than 865,000 varieties of plants, and 200,000 varieties of wheat and rice. Some of these varieties are rare or extinct in the wild. Since 2004, more than $410 billion have been spent on these seed banks. However, and it is estimated that 75% of global crop diversity is not stored in international seed banks. Critics argue that many crop varieties stored in SGSV are not actually used for food, and that the money would be better spent supporting farmers who are growing food crops. Justify the funding. So why have these food crops in seed banks? Now, if we go back to here, right at the start, and this is important because you need to look at everything. SGSV is a seed bank. It keeps seeds from almost 4,000 species of plants, focusing on food crops. So your answer is going to be about food. You're justifying why you're going to have food, okay? Now, why do you need to keep all of these different varieties of food, even though we might think that some are useless or some that we looked at previously last in different times? Well, as I've mentioned before, this is a conservation situation, okay? So you are conserving the genetic diversity of crops. It's really important here to talk about conservation and not increasing, because you're not increasing the biodiversity of crops, because you're just conserving what is already out there. Okay? Now, why might you want to have seeds kind of stored as a kind of a backup, effectively? What things could happen to crops which might make those crops extinct or endangered in their natural environment? Okay, that means you might do this. This is like captive breeding in animals. Why do we keep things in captivity? Well, one of the reasons is so that potentially one day we can reintroduce them. So, protection, but not enough, but from what? And there's all sorts of things: natural disasters, drought, mismanagement. If you look at Mark scheme, you can see all of them. Okay, so protection from whatever. Okay. And that sort of idea, all right? Now, think about what they are. They are kind of random events, because it's saying ignore diseases and pests. They are more controllable situations if you're a farmer. If you've got diseases in your plants, you've got pests, you can attempt to deal with that. If there is a volcanic eruption, or if there is a sudden drought, that's not something that you can deal with. Okay, so you're protecting from those kind of more random, sort of catastrophic events. Right. Why do we want to keep these things? All right. Well, we want to keep them ultimately, all right, for food security. We want to have ways in which we can produce lots of rice or wheat or what else is in there, maize, in the future, because they are staple crop plants. Okay. And we want to make sure that's the case. But if we do have this amazing rice crop which produces lots of rice, why are we not just keeping that one? All right, why are we keeping all these other varieties which might not be as good? Well, what we don't know about the other crop varieties is potentially, although at the present time they might not be the greatest, they might become good when certain environmental conditions kick in. So some of the other varieties, okay, might have resistance to drought, okay, or they might be really resistant to disease or to pests, all right, if that became a problem, or climate change, all right. So it's important to have all these different varieties to conserve the biodiversity, as we said at the top, so that if something came along and caused us a problem, we could use a slightly different variety of crop, all right, to get us through that period of drought, for instance, or increased global temperature. The only other thing I want to mention about this is this idea here. You must be relating this to food. If you start banging on about medicine or, I don't know, textiles or something like that, then you're going to get no marks, because the whole thing is this seed bank company is all to do with food crops and food security. Okay, so there's your last key assessment of topic 4. Hopefully that helps. As always, I hope you guys are keeping safe and well, and I look forward to seeing you hopefully in the near future. Any questions, you know where my email is. Take care of yourselves, and hope to see you soon. Goodbye.